Okay, so we're looking at the 4.7 guided notes, and here we're going to talk about sequences. And really, a sequence is an ordered list of numbers. Now, I want to make this very simple for us because this is something that we can really confuse, and I don't want to confuse this stuff. Just know, a sequence is just a list. Simply a list of numbers. The word ordered just means they're in a particular order, but it's a list of numbers. Nothing more, nothing less. It is a list of numbers. Okay, so each number in the sequence is called a term of a sequence. And this is going to help us keep track of that list. So let's see what that means in action here. So here we're just going to develop the pattern. Just look at the pattern and let's figure out the next three terms of the sequence. So we have 5, 8, 11, 14. What happens next? Well, to get from 5 to 8, we can add 3. And then from 8 to 11, we can add 3. Ooh, this is good. All right, so then 11 to 14, we add 3. So 14 plus 3 has to be 17. So here, this has to be 17. 17 to 3 is 20. And then 23. Oh, that one felt good. Good. So adding 3 every time was the trick, so to speak. For this one, we just simply add 3. And I put this over here just so that we know what's going on. And with sequences, really, we can get them to be very complicated, or we can have them be very simple. It just depends on the sequence. But in general, we're only going to look at some fairly simple sequences. So let's take a look at this another one. This next one here. 2.5 to 5. Okay, so we added 2.5. All right, so 5 to 10. Well, now we added 5. Oh, man. 10 to 20, we added 5 again. Or no, here we added 10. Hmm. Hmm. Well, what 2.5 times 2 is 5. 5 times 2 is 10. 10 times 2 is 20. Ooh, I think we got this one here. So here, 20 times 2 is 40. 40 times 2 is 80. 80 times 2 is 160. So this is our pattern. And here we are, multiply by 2. Multiply by 2. All right. So an arithmetic sequence. Oh, excuse me. This Diet Mountain Dew is really good. Hang on. Quick Trip, you're so good. All right. An arithmetic sequence is the difference between consecutive. Well, I don't like the way I worded that. I should not just write it out of the book. An arithmetic sequence just means that the difference between consecutive terms is constant. So here, the difference between the consecutive terms was 3. Here, the difference between consecutive terms changed, like 2.5, 5, 10, 20, 40, 80. So, so this was an arithmetic sequence. That's arithmetic. This is not. So we'd say not arithmetic. And this one is arithmetic. All right. So, what do we know? If the difference is the same every time, we call it the common difference. That's the common difference. Okay. So, all this asks is for us to determine if the following sequence is arithmetic. Okay. 8 to 5, we add 7. So the difference there is 7. I'll make note. The difference there was 7. 5 plus 7 is 22. So that's the difference of 7. Should we be good? Let's check again. 22 plus 7 is 29. Ooh, wait. We added 8 that time. So the first one is not 7 to 9, we add 2. 9 to 11, we add 2. 11 to 13, we add 2. So this one's 2, 2, 2. Yeah, check. Yeah. Yes, this is arithmetic. Alright, 2 to negative 2, we subtract 4, add 4, subtract 4. So minus 4, 4, minus 4. So is this the same? No, so this is not arithmetic. Okay, so 10 to 4, we subtract 6. Oh, subtract 6. 4 to negative 2, we subtract 6. We're on a roll here. Negative 2 to negative 8, and we subtract 6. So yes, this is indeed arithmetic. All right, so now our next term that we need to know is recursive formula. No, this is not writing in cursive. Ha! This is a recursive formula. So it's a function rule that relates each term of a sequence after the first one, so not including the first one. So each term of the sequence relies on the one before it. So let's learn some of these symbols here. N is the number of the term. So like the sixth term would be the value of n would be 6. A of n is the value of the nth term of the sequence. A of 1 is the value of the first term of the sequence. And A of n minus 1 is the value of the term before the nth term. So let's see how these play a role for us here. So we're going to write a recursive formula for the following sequence. Well, this is one of those things that I'd like to do whenever I get these. I want to ask myself, well, what's my common difference? So I have 7 to 11 is 4. So here's my 4. 11 to 15 is 4. 15 to 19 is 4. Okay, so I have a common difference. So this is arithmetic. That much we know. Now my first term, so my first term, my 1 being my first term, the value of my first term is 7. The value of my second term is 11. The value of my third term is 15. And the value of my fourth term is 19. Okay, so we know they all have a common difference. And with a recursive formula, it's going to be defined by the previous term, the value of the previous term. So for A2, and we really start with A2, 11 here. Well, that's really what this is saying is A1 plus 4, right? Where A1 is 7, so it's 7 plus 4, that's 11. And then we could say that A3 is, well, since it's 15, we know that it could be A2 plus 4. And A4 then would be A3 plus 4. So what we could see here is that the fourth term is defined as the third term plus 4. The third term is defined as the second term plus 4. The second term is defined as the first term plus 4. And the first term is given. This one we cannot define as anything other than 7. So now we want to decide, how can we say this for any term? The nth term. my nth term, a n. Well, here's 4. 4 minus 1 is 3. All right? 3 minus 1 is 2. 2 minus 1 is 1. So here I have n. So I want to say a of n minus 1 plus 4. And now I have my recursive formula. Again, a recursive formula is a formula that defines the term by using the previous term. The previous term has defined my term here for me. Okay? Now, I think we're going to have a worksheet over this. So if I didn't hand it to you on Friday, which is today, I guess, or this weekend, then we will work on this first thing Monday.